We're going to start our unit on geology by jumping ahead to chapter 4 to introduce to you the structure of the earth. Sometimes an egg is often used for us as a comparison or an analogy to how the structure of the earth is organized. If we look at an egg actually has some distinct layers. It has the shell, which for the earth would be called the outer crust, and the shell can be cracked and so on. And then if we look at an egg that's cooked, of course, we have the white layer, and that would be the mantle for the earth. Then we have the yolk, which would be the core. And there are two kinds of cores, which we'll look at, the inner core and then the outer core. So often, as I said before, an egg is used to compare to how the structure of the earth is. Some people have different theories in regards to how the earth formed. One idea was something called the Big Bang theory, and the sun formed from there, and then as different matter started to rotate around the sun, gravity helped bring together different bits and rocks, and then the earth core formed, and then the oceans and the atmosphere formed after that. So here is a blown up picture of the different layers of the earth. We have the earth's crust, which is approximately 0 to 100 kilometers thick. The crust is made of basically continental crust as well as crust underneath the ocean. Then we have the mantle, which I talked about before. There's actually a solid portion of the mantle and then a liquid portion of the mantle. Then in gray here, you'll see the final layer, and that's the core. So there's the outer core, which is liquid, and the inner core, which is solid. So you can see proportionally, the crust is just a tiny shell-like section, then the mantle, and then the core, the inner and outer. Here it is again. The earth is composed of 4 layers: crust, mantle, outer core, and inner core. How do we know this? What have we used? What kinds of technologies have allowed us to actually come up with this idea? And unlike the movies, we haven't actually been able to dig deep enough. And so we've had to use different kinds of technologies. For example, earthquake waves can be sent using seismic waves, and they'll bounce back at different speeds depending on what we're running up against. And so one way that we've learned about the thickness and layers of the earth was through sending out something called seismic waves, which are earthquake waves. We've also had other methods. So we've used satellites, especially to give us an idea about the crust and the ocean crust. We've dug boreholes, and we've got certain mines that have gone deep enough. So again, here is the crust, and there are actually 2 sections: the crust underneath the ocean, which we call the oceanic crust, which isn't very thick. It's about 8 kilometers. And then, of course, the continental crust, which is very thick. The Earth's crust is not actually stationary, and it's broken up into tiny plates, which we'll learn about later, and they float. Okay, they float on what's called the mantle, or part of the asthenosphere, and the movement of these crustal plates, or the floating of them, helps generate all sorts of different dynamic events around the world. So here it is again. So the continental crust can be, depending on where you are, as much as 100 kilometers thick. Incidentally, the deepest hole we've actually drilled into the crust was in Russia, and it was only approximately 12 kilometers. So that's as far as we've ever gone with a drilling rig, or to drill, or borehole it's called. Here's the ocean, and then we have the underneath the ocean, the oceanic crust, which is about 8 kilometers, obviously varying. And then we have a rigid part of the mantle and then a liquid part of the mantle. So this whole solid, which includes the rigid mantle and the oceanic crust, we call that the lithosphere. And below that, the liquid part of the mantle, which flows, which moves through convection currents, that's called the asthenosphere. So let's look at the lithosphere again. So what is that? That's the solid part. Okay, the lithosphere is the solid part. It's made up of the crust and the upper layer of the mantle. Here's the mantle then. It's the middle layer. The liquid part is called the asthenosphere, and it has convection currents occurring in it, which help to move the crustal plates around. Excuse me. Excuse me. So that's how we get all this activity. So if you remember from heat and temperature, convection currents happen due to unequal heating. So hot liquids rise, and then as they get away from the heat source, they sink, and then they rise again. These convection currents occur in the liquid part of the mantle. And so what if this cork was sitting on top, which is, the cork would represent the crustal plate? What would happen is it would move maybe this way if the current was going, like convection current was this way, or it could go this way. Let's talk about the outer core now. It's approximately 1,400 miles thick. It's made mostly of iron and nickel, and it is liquid. Okay, whereas the inner core, believe it or not, is solid. And so some people think as you get deeper and deeper, it gets hotter and hotter. We're going to talk about how is it that the inner core then is still solid and the outer core liquid. Well, the inner core has temperatures and pressures so great that the metals are squeezed together and not able to move about like a liquid. And so that's part of it. Okay, due to extreme pressure. And there's also way more iron in the inner core, which helps to keep it solid. And this iron in the inner core helps create the Earth's magnetic field. Okay? And so that's a brief overview of how the structure of the Earth works. Later on, we'll talk about how plate tectonics and other things.